Good day, fellow. Setso is back. Today we are going to do some redox reactions. Some redox reactions. They simply implies the transfer of electrons. For today we are going to consider this equation. Zn plus NO3 minus Zn 2 plus NO2. Then we are going to balance this equation in an acidic and as well in a basic way. Then how are we going to balance this equation in an acidic? First, then so simple. We are going to consider our oxidation numbers for each and every element. Let us find the oxidation numbers of each and every element in this given equation. It is so simple. For zinc, we have a pure element. Zinc is a pure element. Its oxidation number is going to be 0. So simple. Then for us to find the oxidation number of N, we must go to our periodic table to find the oxidation number of O. It is usually -2. Then from here, we are going to equate its overall, which is -1. Let us go and find oxidation number of O is -2. Then it's going to be N. I have 1 N, you can clearly see, plus 3 of O. Then inside I'm going to insert -2. Then let us solve. This minus this, I get -6 minus 1 N. Then I take 6 to that side. Going to be +6 minus 1. Our final answer is +5 for N. Then lastly, O, it is usually -2. Then now, let us consider our right hand side. I have an ion, zinc ion there. Its oxidation number going to be its overall, which is +2. So simple. For us to find N, let us equate to its overall charge, which is 0. I have nothing there. Then I'm going to say N plus 2 of what? You open bracket and insert -2. Going to get -4 equate to 0. And N, that means our N is going to be +4. Then lastly, our O, which is going to be -2. Then from this, we have found the oxidation numbers of each and every element. Then now, we are going to look at them from left hand side to the right hand side. Check. For zinc, we have 0 oxidation number. Then afterward, we had 2. The oxidation number of zinc has increased. The moment the oxidation number increase, we say such is an oxidation. That means zinc, it is oxidized. Then now let us check the oxidation number. It increased, but now if we check for N, it was 5 before, then after it was then what? +4. It has decreased. Then it's going to be reduction. That means N in this case, it is reduced. Then from here, we are going to write some half reactions. Then the half reaction of zinc is going to be, we are going to do it like this. We are going to take zinc, or let me just start. Let me just start with zinc. It's going to be Zn. Then you write this. Then on our right hand side, we said we have +2 for zinc. Then now, how are we going to balance this? Firstly, we are going to balance element. Secondly, we are going to balance those charges. You see, normally I call it pair, pairs, like pairs like pairs. We balance electrons then charges. See, balance electrons, sorry, elements, E for element, then charges. Then for us to balance element, you can clearly see I have one zinc and one zinc. Zinc is balanced. Then for us to balance charges now, this side I have plus 2 on my left hand side. Somehow I have an oxidation number, or its overall is 0. You can write with your pen 0. Then how are we going to balance the electrons? Sorry, the overall charges. Because this side I have plus 2, on my left hand side I have 0. Then you are going to do it like this. On my right hand side I have plus 2 plus 2. Then on my right hand side I have 0. On my right hand side I have 0. What number, or in a simple ways, just say 2 minus 0. 2 minus 0. 2 minus 0, you get 2. You see, it's so simple that way. You say this 2 minus this 0, then you are going to get plus 2. Then you plus 2, you put it this side. Why do we put it on the right hand side? Because it is our oxidation. We always put the electrons on the right hand side. Or in a simpler way, it means if now I have 2 positive charge, then I subtract it with 2 electrons. At the end of the day, I'm going to get 0 watt charge. You see, for me to get this 2E in a simpler way, I said 2 minus that 0. Then I got plus 2. Then I write it 2 electrons. Then this one would represent what? An oxidation. See, the oxidation. See, then yeah, now we are going to consider NO3 minus together with what? With NO2. Firstly, we are going to balance what? Elements. I have one N balance. But for O, this side I have 3. I have 3 oxygens. On my right hand side I have 2. To make my oxygen to be balanced, I have to add water. Then now you are going to add, to balance your elements, especially for oxygen. In this case, I'm going to add water. Then how many O I'm going to have now? 2 plus 1, which is 3. On my left hand side I already have 3. But now look, something will change a bit. On my right hand side I've added water. Water is 2 hydrogens. Then for me to balance this one, what I'm going to do from here, I'm going to add something on my left hand side, which is hydrogen ions, 2 of them. I'm going to add 2H plus. I'm going to add 2H plus for them to balance the others on my right hand side. Now I have 2 H's this side, 1 N, 3, as well as 3 that side. Then now from here, I've managed to balance my electrons. Now let us balance our charges. For us to balance our charges, you are going to consider overall. Check. I have a compound. Its overall charge is 0. I have nothing. Then I also have water. Its overall charge is 0. Nothing there. Its overall, not just O, but its overall is 0. 0. But for this one, I have -1. For this one, I have +1. But how many H's do I have? 2. I have 2 H's. Somehow I'm going to have +2. When I subtract it to this one, which is -1, the overall charge on my left hand side is going to be +1. This is the overall charge on my left hand side. On my right hand side, we said we have 0. We have 0 this side. We have 0 charge this side. Then now, how are we going to balance these charges? It's so simple. Again, you go to your overall, which is +1, and subtract that number. Say 1 minus 0, like as we did there. 1 minus 0, we are going to get +1. Then that +1, you write it here. +1 electron. You see? You write it on your left hand side. At this point, we have what? Reduction formula. Reduction formula. Don't forget that these two, oxidation as well as reduction, we identified them where? There. Because as for zinc, we managed to see that the zinc into oxidation numbers increased. And whenever they increase, it's going to be oxidation. Then for N, we saw that it was 5. Then after it became 4, it has reduced. Sorry, it has decreased. Then whenever oxidation number decrease, we say such is what? The reduction. Then yeah. At this point, I'm going to have two equations. Two equations. I have this one. I have this one. Let me write it. I have this one, zinc. That N 2 plus it 2 electron together with this one of 1. Yes, it's 1 plus 2 H plus NO 3 minus N 2 plus H2O. Then now I have two equations, the first one and the second one. Then for us to write a net equation, we have to balance the electrons of equation 1 together with equation 2. On my equation 2, I have 1 electron. For them to be balanced, I'm going to multiply everything by 2. It's much simpler that way, by 2, to make it look the same as that one. Then it's going to be 2 electron times 2 is going to be 4 H plus 2 NO3 is 3 minus, then 2 NO2 plus 2 H2O. At this point, I have 2 and 2. Then yeah, now it's fine. They are going to cancel each other. Then from here, I can then write what? My overall net equation. Then I'm going to cancel this 2 together with that 2. Then it's going to be, you write everything which is on your right together. Like Zn, you see I have Zn plus 4 H plus 2 NO3 minus. Then on my right hand side, I have Zn 2 plus 2 NO2 plus 2H2O. You see, at this point, I have managed to balance my equation in acidic form.